This brief video compares and contrasts the use of the Precipitation Frequency Data Server operated by NOAA, the EBD Lookup server operated by myself, which is largely adapted from the EBD Lookup 2015 product that was built for and is in current use by the Texas Department of Transportation. As of October 1st, 2018, the federal data was published and made available to the public, and that data deprecates the utility of EBD Lookup 2015. There's a research group, I believe at Texas A&M University, that's working on an update for EBD Lookup, but in the interim, what we have here is a way to take advantage of the new data from the Precipitation Frequency Data Server, as well as the ability through log-log interpolation to estimate rainfall intensities either by partial duration or annual maximum series for any location in the United States that the Precipitation Frequency Data Server provides tabular data for. So we're going to do an example from a place in Texas just to illustrate how to do it. Okay, the website you see here is theodore-macbookpro.ttu.edu, and it's a research and development website that's maintained by myself at Texas Tech University. And in it there's a tab called Toolbox, and if you select Toolbox, you're presented with a screen here. In that there are Texas-specific hydrology tools, so the EBD Lookup 2015 and the associated Texas Hydro 2015 are provided there, and you'll see the notation that indicates that these tools are obsolete as of 1 October 2018. There's some older tools, the Texas DDF Atlas and Texas Regression Equations is unrelated. But now there's this new tool, which is log-log interpolation for new use with NOAA Atlas 14 data server. And we'll go through how to use this shortly. It's also available in interpolation, and because I think it's of utility to the other users in the country, I also included in the general hydrology tools. Let's first use EBD USA, which is a prototype of a nationwide tool that estimates rainfall intensity by county in the United States. It uses a database that was built from data that was recorded from the NOAA Atlas 14. However, that data download predates the October 1st, 2018 release of the new Texas data. So this particular tool I'm about to show you uses old Texas data. Okay, so to use it for Texas, you would select the state, select a county. I'm going to choose Lubbock County, I guess. No, let's go to the coast. I'll pick Aransas County. There should be differences in the data. And let's suppose that we have a small drainage area and it has a time of concentration of 49 minutes, and I'm arbitrarily choosing that value. English or SI units, we'll select English. We press submit, and what has just happened is this has performed the identical calculations that the EBD Lookup 2015 would have produced. Okay, let me see. I'm going to leave that available, and hopefully this will work. Okay, so now we're back to here. The other tool in the toolbox is the interpolation tool, and we'll go through general hydrology. It all links to the same place, and the interpolation tool is not quite as pretty as the other one, but what we're going to do is we're going to go to the Precipitation Frequency Data Server. We'll go to Texas. We'll go to Aransas County, or at least my best guess of it, and should be, let's see, I think that's going to be close. I may be a little off. I could actually enter the latitude and longitude of the centroid, but I believe this will be sufficient. And you'll notice here that right now it says PDS-based precipitation. That means partial duration series. It's in inches. And we actually want intensity. and I'm going to choose annual maximum because that is the same type of analysis that was used to build the EBD lookup. So now we have our confidence intervals, our information in inches per hour, and you'll notice 49 minutes is nowhere on this tabulation. If we go to EBD lookup, let's look at 49 minutes for, we'll use the 10-year as a test case, was 3.47 inches per hour using the older Texas published EB&D values. And it's for a 10-year storm. And so I believe if I go to here, we can look up the 10-year, 1 in 10, and the closest to 49 minutes is somewhere between 30 and 60, and that is 4.70 inches per hour at 30 minutes and 3.15 inches per hour at 60 minutes. And so what we would want to do is interpolate between those two to get an estimate for 49 minutes. We, however, don't necessarily want to do a linear interpolation, because if we look at the graphical representation, we'll notice that these aren't straight lines, and we're actually in a logarithmic scale on the horizontal axis and in a logarithmic scale on the vertical axis. So we could attempt to do a lookup from this chart, but the interpolator tool is created with the intent of being able to make those interpolations relatively rapidly. So let's go to the intensity interpolator. I've written down the two values. I've written down the 30-minute and the 60-minute, 30 and 60. And you could switch between the two objects, but I'll just type it in because I can. So we want to put our duration that's smaller than the one of interest, so that's 30 minutes, and it's prompting us for an intensity of inches per hour, which is 4.70. Our high value is 60 minutes, which is 3.15 inches per hour, and we're interested in the behavior at 49 minutes. So once that data are entered, we press determine intensity, and it estimates a value of 3.54 inches per hour. Now that's a little more difficult than using the EBD lookup for county. What's also important is you'll notice that the estimate of intensity from the earlier tabular values produced an estimate of 3.47 inches per hour, whereas the updated values, which include recent data that was not available to the researchers that created this document that you see here, the newer one is 3.54 inches per hour, almost a tenth of an inch an hour more, and a tenth of an inch an hour over 10 acres would produce an extra cubic feet per second of runoff. So there is a difference between the newer results and the older results, at least for Aransas County using these tools. We'll pick one other example just for grins. I live in Lubbock right now, so we're going to choose Lubbock County. And let's do something that's, well, we'll do 75 minutes. And we'll again focus on the 10 years. So 75 minutes produces 1.71 inches per hour. And we'll go to the precipitation server. We need to move our target. Let's see if it'll let me do it. Oh, it will. We'll put it on Lubbock. That should be pretty close to the centroid of Lubbock County. Annual maximum series, so we're in the right series. And now we have to realize that 75 minutes is going to be between 60 minutes and 2 hours. So it's going to be between 60 and 120 minutes. We'll again focus on the 10-year. So we want 2.18 at 60 minutes. So we'll supply the duration. Our interest is 75 minutes. and we want 1.3. And our new duration is 120 minutes. And you, the analyst, are going to have to keep track of whether you're going to enter this stuff in inches, in minutes, or in hours. Choose the term in intensity, and it produces a value of 1.85 inches per hour, and which again is, that's again a tenth of an inch, more than a tenth of an inch higher for Lubbock County. Clearly the EBD lookup is a little bit easier, in my opinion, to use, but we now have a tool that allows you to estimate in a continuous sense any duration you want for a particular frequency estimate. Now, I don't know if we hold a row straight if log-log interpolation between probabilities makes any sense at all. That's not something I've examined. So this is intended to work column-wise. And that concludes the how to use the Rainfall-Intensity-Interpolator for use with a NOAA PFDS server. I need to change that. And there's also going to be a link here in the version that you get to see that goes to this video. Thank you very much for your attention. Please enjoy the tool. If you are interested in what's going on under the hood, you can show the page source, and it should show you the JavaScript that's going on underneath the hood.